So thank you for this. I have a couple people who have turned in their take-home test. It's not due for a couple weeks, whatever. But y'all all have a copy of it, right? Was there anybody that was out that did not have a copy of this? You didn't have one, Michelle. And I actually don't think Amanda did. She just stepped out. So, okay, so this is, you do what's required of this, right? So scrap the pen take-home test. It's due in a couple weeks. I think we said something. Yeah, so I said by the end of March, but you know, as long as it's close, okay? We won't go over it as a class until everybody has turned theirs in. And the one specification for it was that you do it on your own and you don't ask anybody else for help or get any help from anyone else. So thanks. Let's go ahead and go over the lecture quiz. Hopefully that it seems fair to you. So let's see. The first one says name 3 factors that might affect the person's risk of disease. It was an entire list, right? You could probably, without a lecture, have come up with something that puts a person at risk for infectious diseases. What are some of the things that you said? Age. Absolutely. Heredity plays a role. Yeah, so the environment certainly plays a role. People can actually live sometimes in too clean of environments, can't they? And then they can be also in environments that are not healthy or whatever, and put them more at risk for disease because they're exposed. Overcrowded conditions, can that expose people? Yeah, what you said? Their immune system, so they can have immune system issues. So that's like pre-existing types of conditions. We said pregnancy, stress factors, cancer as being like one of those pre-existing things that can happen. People who are on medications for whatever reasons. Is there any such a thing as a safe drug? No, there really, you know, wouldn't that be wonderful if there was this magic bullet drug that you could give to someone and it would just absolutely treat what they have, but wouldn't in any way compromise them in any other way. So revisit that list because I think that can really help you. How about even gender? Does that play a role? Yeah. So you know all those things, diet, which part of the environment. So you could have come up with something. Hopefully you did. Define the term pathogen. It's really considered almost anything that has a potential to cause disease is considered to be a pathogen, right? And we know we're actually most things that become pathogenic are actually opportunistic pathogens. They take advantage of that list of factors that have happened and cause disease, right? So, right, what's meant by the IV or the infectious dose of an infectious causing organism? What's meant by that?
How much to cause sickness?
Say it loud for me, Casey.
How much it takes to cause sickness?
Yeah, so for infectious diseases that we know cause disease, we know there's an actual number that it takes before it can overcome your immune system. So, and that number is really different for each of those infections. And do we know the number? Yeah, we do. Well, we don't each have to know them individually, but we know when there's an epidemic going on, how frequently these diseases can move through a population because of that. So obviously the ones that have very low ID dose are going to be ones that we're really concerned about because they're going to end up having potential to really wreak havoc, right? And others of them, you're going to have kind of a significant introduction to them before it would take over somebody's healthy immune system. So it sounds like the key here is to keep a really strong immune system, right? And reduce some of those factors that we know that can contribute to diseases. So distinguish between an exo versus an endotoxin. Who has an answer to that they would like to share? What'd you say, Jared?
Exotoxins are excreted from outside the microorganism, and endotoxins are within the organism.
So exotoxins, they're made inside the organism, but they're released to the outside. So right, they're secreted, they're released into the environment, where endotoxins are actually, inside the microorganism. And maybe some of you even remember that gram-positives we associate with exotoxins and gram-negatives with endotoxin. And the significance of this is that we would be thinking about what organism is that we're treating, because if it's one that makes an exotoxin, are we going to have to deal with that exotoxin? And potentially, like, make sure that we are ready for an antitoxin with that. So, okay. Define the term teratogen, and we've had this before. So what did you put? What is it? Yeah, it's harmful to a fetus. Explain what's meant by the term sequelae. It means a secondary infection. So it's the secondary thing that you might be expecting because of this one infection. Sometimes when you are treating disease, and it's important to understand that, sometimes when you're treating disease, you're actually really treating the potential sequelae, not the real disease, but you're trying to prevent what could happen secondarily. So great. Give an example of a vector. It's something that transports or carries. Which ones did we talk about the other day? We talked about ticks, but there's mosquitoes, there's ticks, there's other animals, there's humans. Humans are really vectors, right? Of human diseases, but we were talking about ticks. Borrelia burgdorferi is the etiology of Lyme's disease. Lyme's disease. Was that a fair question? Borrelia burgdorferi, I'm having people say yes, it was. So it means that if you didn't have that highlighted on your chart, make sure you do, because really you don't want to be waiting now. Even a couple weeks from now, if you're not looking at those charts and being very familiar with names of organisms, what group they belong to, and what diseases they cause, it's going to be a rough last 2 weeks in this class for you. Okay, so make sure you're looking at those and kind of staying up. I didn't ask this, but I could have, because so many of you had it on your study guide. What causes Rocky Mountain spotted fever? Rickettsia. And what group does it belong to? It's a bacterium. It's a bacterium, right? Right. So that's the kind of thing you're going to be wanting to be really, really familiar and up to date with. So define neurotoxin. What's a neurotoxin? It's something that is poison to our nervous system. So it's a toxin that's going to be targeting neurons. And, no toxins are good, but certainly ones that are neurotoxic, of even maybe more importance. So the terms communicable, infectious refer to what? What'd you say? Yeah, they're spreadable. That's exactly right. So it's referring to how easily maybe certain diseases can be spread within the population. So that's great. Name the protozoa suspected if a string test is ordered. Giardia lamblia, which is again, I said protozoa, right? Do we have normal protozoa even in us? Yeah, we do too. We do. And some they're usually friendly, but this particular protozoa is not. And so yeah, and whatever. They still do string tests, believe it or not. Anyway, especially if stool cultures have been negative. All right, and they suspect that. So any questions for me? Were these fair questions from lecture? Okay. All right, great. I had kind of promised you that that these next couple of chapters are things they're things we're revisiting because we've used some of this terminology. So hopefully you're feeling like that. When I finish chapter 11, you're going to put a big thing in your notes to say that's the end of the material for this next test that we're going to have in here, which is multiple choice test based on just lecture, because that's all we have in here, right? What I ask you questions based on what our lecture is. This is why people should definitely be looking at the study guides that people have done. When do you all want that test? We'll finish this up in just the next few minutes, chapter 11. But when would you all want this test? Did I already say when it would be? I've forgotten. I didn't say. All right. Well, I would like it for it not to be next Monday. And I don't think any of y'all want it Wednesday. Do you want it Wednesday? Kristen's like, no. She rarely is going to but she still, no, I don't. So I'm going to listen to her because you know what? When she speaks, I'm listening. So not Wednesday. And by the way, I don't want it Monday. So can we just say it's going to be pushed back even to that Wednesday? All right, so you all have plenty of time to look through those, make sure you've got good notes. If you, for some reason, don't think you've got good notes in here, I bet there's some people in here who have really good notes. And they would probably either let you copy them, you know, Xerox copy them, or scan them, or do something. Take pictures of them. See, you know how lucky you are that you can take a picture of somebody's face. What'd you say?
We want to do people.
Is that what that date is? So it is not.
Next one. Oh, wait.
No, it's a Monday.
It's 27. I thought you said you get one.
All right, I don't want to do it. I don't want to do it next week.
Monday.
Wait a minute. I don't want to do it next Monday. Okay, so it's the 27th, right? Okay. It's the 27th. Yeah, that Wednesday. Yeah. Yeah. Thank you. Y'all keep me. And we had tentatively said that take-home test would kind of be due that day too, but that is flexible. The take-home test, right? The take-home test is flexible. Yes.
What chapters is this next test?
I don't know. Just since the last test. So go back and where you marked. I mean, I don't know chapter numbers. I'm not trying to be. I just don't know chapter numbers. So the last where you stopped on the last set of information in your notes because you had a big stop sign. Pick up right then. I think Brittany knows because she and Rebecca had said something about it. So y'all can get with them later and ask that because I don't know numbers. But it'll be from where we picked up at the last chapter that we tested on. So again, we had talked about a lot of this. Where did we stop?
I remember we were talking about sequelae.
Sequelae. Okay, thank you. And you all did know what that was, right? So latency, you said it means they can lie dormantly, but it's going to stay in your system. Some people will never have trouble with a latent infection, certain ones, but other people will. And we did sequelae as well. Now, so this next part, I think I've talked about, but in case I hadn't, make sure that you get this well, so that if you had a question about any of these different times of infection throughout the body, you would be able to recognize them. Jared, you have another question?
Yes. When you went over sequelae after the test, you said it was a secondary infection. But
Well, it's a secondary, it's something that can happen. And sometimes it's another infection. Sometimes it's actually just a something that can happen because of. So I gave you some examples. I said that the reason you get treated for strep throat is not because of your pharyngitis, is it? Why do you get treated? So your kidneys won't fail with acute glomerulonephritis, and so your heart valves won't give out with rheumatic fever, and that's why. I also maybe mentioned to you that like people, and I did this in A&P this morning, people who have viral pneumonia get an antibiotic. Is the antibiotic helping them for the viral pneumonia? Is it? Not at all. What is it doing then? It's preventing them from getting a bacterial infection on top of their viral pneumonia. Viral pneumonias have a very low mortality rate. But guess what has a really high mortality rate? Bacterial pneumonia. And you have just given yourself a factor that predisposes you for getting bacterial pneumonia if you have viral pneumonia. So that's a sequelae that could potentially happen. Get what I mean? So this is what we are talking about when we say a lot of times what we're trying to do is just prevent those types of things from happening. So sometimes treatment might not on the surface seem like that it's directed, but it is directed if it's trying to prevent sequelae. Right? Okay. So that's what we do. Now here, I think this next, I'm gonna skip to this, but this to me is a visual graph that sort of helps you to understand. For each disease, whether it's measles or mumps or rubella or strep throat or any of these diseases that you might get, influenza, there is this initial exposure. There's this initial exposure. Then there is a known incubation period. So for example, like varicella zoster that causes chickenpox, its incubation period is almost 2 weeks. It can be longer than 2 weeks even. So it can actually be longer than 2 weeks, 2 weeks to 3 weeks. And during that incubation period, now some incubation periods are as little as a few hours. But we know with these what their incubations are. So this incubation period, do you have any signs and symptoms?
Probably not.
No, and you don't. So if there's no signs and symptoms, but with some of these infections, can you still be infectious? Yes, you can still be infectious. So again, important to kind of understand that. And then there's going to be this phase called the prodromal stage, if you will, phase or stage. And during this prodromal stage, you're going to be getting this, just the beginning of signs and symptoms that might not seem too acute, right? So you're just sort of at the beginning. It's referred to as prodromal stage. And then all of a sudden, you've got this height of infection, this period of infection and disease. And then you'll start to get better. Why do you start to get better? Because you have antibodies? Okay. Because your immune system is strong, and your immune system is going to start fighting it. And hopefully, as your immune system's building against it, your signs and symptoms are going down, and this is referred to as the convalescent period. So I want you to just be familiar with these terms or these stages or periods, if you will, because for each infectious disease, we know how long the typical a person stays in each of these stages. And that can help us to understand how to control the spread of disease. If we have, this has been talked about with like smallpox. Y'all know that we don't get smallpox anymore, right? Because it has been eradicated. But this was devastating to populations because it moved through populations like wildfire. One of the reasons it did is this incubation period, while the people were still infectious, were so long. So it wasn't like you could just stay away from a house of people or a village that had smallpox. You found out there was a smallpox case or whatever, because you could have actually been exposed to it many days ago and not known, right? So we kind of get that, and we need to understand that. And epidemiologists use that in figuring out how long they should keep quarantine timing in and how to control, right? So they use that depending on what type of epidemic is actually going on in that area. Do you think they're using that with the measles outbreaks and the mumps outbreaks that are going on right now and all of that? They really are. And they use that to come up with the reasoning behind how to control those infections. So let me see if, so you got this in writing, too, but I sort of just explained to you how some of that is used. So great. I'm going to try to go by the notes so I don't forget anything. But I had told you guys that sometimes, humans definitely are going to be able to spread disease, but you can also have these arthropods that are. So insects certainly can do that, and we think about mosquito. Y'all heard of the Zika virus, haven't you? So maybe this is one, if you hadn't heard of it, you're writing it down. The Zika virus, what do you know about it already? What'd you say? The Zika virus was in the news a big time a couple of years ago because we were realizing in infectious disease that women who had history of having had Zika virus early on in their pregnancies and they were looking at numbers of these babies being born with microcephaly. Y'all know what microcephaly means? If it's broken down, cephaly means head, right? And micro means small. So their brains were underdeveloped, and there were craniofacial anomalies that happened too. And these infants are they're seriously kind of devastated neurologically. So are they going to ever be able to reach full potential with this? No. So they were noticing that microcephaly births were really increasing. So what they did was they went back and looked at what else was increasing at the same time. And what they noticed was a correlation between confirmed Zika virus infections and these women. And so then they tried to see, is that really true? So they took some babies that were born that had not survived, and they tested the brain tissue, and guess what virus was there? Zika. So do y'all remember this now? A couple years ago, they were warning people to not travel to, or if they did travel, it was during the 2016 Summer Olympics in Rio. That was in Rio, right? Am I making that up? So it was in Rio. And they were warning people. Some athletes decided not to go. Because it's not just women. What they knew was that men who had had the Zika virus infection, they could keep it in their semen for even up to a couple of years. They were being advised to not start a family for a couple of years. So this is still, they're still doing all those warnings and whatever, but what we know is the weather's changing. Whether you believe climate change or not, please do the research before you make a decision on anything. But anyway, this is now, these mosquitoes are, this outbreak isn't just limited to Central and South America. It's in Florida and even parts of Texas. These mosquitoes are we actually had those same mosquitoes here in Virginia. Now, I think if you look at the CDC site, you would see that the only ones that have actually contracted Zika that didn't have travel history are, I think it's Florida and Texas, it's a few southern states. And the reason being is that the mosquitoes are staying around longer, the climate, it's hotter, it's wetter, longer, and this has actually moved. So this is of concern, isn't it? All right, any questions for me? So I think the initial illness with Zika, it has, all illnesses have a mortality rate known with it, but that's pretty low. So it's not like a person, it's not a high risk of dying of the Zika virus yourself. It's just that it is extremely teratogenic. And when I say just that, that's huge, isn't it? That's important. And it's not just women, it's men too as well that can actually transfer this. So we have arthropods, but then we have non-living reservoirs, which actually, a lot of diseases that are so devastating now, it's through water contamination. So soil, water, air, and even, have y'all heard of sick building syndrome? Have y'all heard of that? Janet, you have. Where have you heard of that?
At work, I guess. I'm assuming.
All of us at work think our buildings are making us sick, no matter what work you do. Michelle, tell the truth. You can think that too. Yeah, no. But you have heard of it at work. Well, there are really some local cases that this has happened. There's a school in Bedford, Virginia, where the entire elementary school had to be shut down because they realized that quite a few of the kids had developed not just respiratory disease, but they had like crazy numbers of type 1 diabetes being diagnosed in this one area. So what is type 1 diabetes? Insulin-dependent diabetes mellitus. What's the cause of that? It's an autoimmune disease. And for those of you who don't know what that is, because I have a few people who are new to me, an autoimmune disease means your immune system is attacking your own cells. So in type 1 diabetes, these people's immune systems have turned against their beta islet cells and are attacking those cells. It usually does this, we know this, because those antibodies are cross-reacting with something that they had been made, like they should have been made to, in the environment. So the question was, is there something in this school or in their environment that is causing them to get sick? And that might not be causing them to get very sick, but sick enough that their immune system produces this antibody that's cross-reacting with their beta islet cells of their pancreas. So what they did was they went into the school system, and this is just one example. There's been a lot of these examples of sick building syndrome. They went into the school and they found a type of mold that is mold. Is mold normal in our environment? That, like, there's none of you that live in a house that's without mold. I mean, you might think you do, but you don't. And, some of us live in houses that have a lot of mold because they're old houses. They have cellars or whatever. And it usually is part of our environment, but depending on the type, we see more diseases. And this particular school really got shut down, the elementary school, because of this particular type of mold that was there until they could come in and absolutely, try to take care of it. I think they actually moved up there for a new school, a whole new school. So, water, this is the way that we know the cholera outbreaks happen. And cholera is a disease, in case you didn't know this, if we hadn't mentioned it, it's caused from a bacterium known as Vibrio cholera. Vibrio cholera. So this bacterium is so easily spread through people defecating, and then if there's not clean water supplies, it's a fecal-oral route of transmission, but it's often in contaminated water sources. So, and it can really be devastating. It causes in the patient something called rice water stools. And this is one of the things that we sort of recognize with cholera. What will happen with the person who has this is that they will be producing just water from the rectum. If you go to areas that have had like earthquake, areas that have been compromised, their water systems have been compromised because of natural disasters like hurricanes or earthquakes or whatnot, you'll see usually tons of deaths after the event. And the deaths after the event are because of these infectious diseases that happen because the water systems are down. Haiti, that earthquake that killed so many in Haiti not that long ago, just as many died later from cholera. That's kind of sad, isn't it? It really is. So this rice water stool thing, what happens is people get ill and they literally are just leaking fluids from the rectum. And it looks like water in a glass that you put a few pieces of rice on top of. That's what the stool looks like. It's just fluids. Can you stand the loss of that many fluids in that short a period of time? So what am I telling you is usually the cause of death of people with lung? Yes. Yes. So, vectors. We have to know about vectors. And some are living vectors. What's a carrier? What does that mean, a carrier of disease?
Bacteria.
What'd you say? Yeah, so you have it, but it's not causing you to be sick. But can you give it to someone else?
Yes.
And could they get sick from something that you're giving? Yeah, absolutely. So asymptomatic carriers is what you kind of just described. And then you're looking at some of the other distinctions. And I think it would be, these kind of make sense. So incubating carriers mean that you're in that incubation period. You didn't even know you had it yet because you don't have any signs and symptoms. Convalescent, did I tell you that you could be infectious even though you're getting better? Yeah. I cannot tell you how many people I see who's, in the grocery store or whatever say, how have you been? I'm good. I just, I've been on treatment for a couple of days for flu. I was like, really? Why are you here? Or are you in the grocery store with little kids and stuff? But anyway, chronic carriers are people who just kind of keep it. And then sort of passive carriers is another, like especially health professionals. I want you to write down the word nosocomial. Have I given that to you before? Nosocomial. I'll spell this. Nosocomial. Nosocomial. Just like it sounds, nosocomial. I want you all to also know Nosocomial. Y'all should see y'all looking at each other's papers. Nosocomial. I want you to know the term because you'll hear it. You'll hear it in exams and stuff. Not in my class, but in class and that kind of thing. It's also referred to, nosocomial is sometimes called hospital-acquired infections. HAI. You'll see that abbreviation, HAI, hospital-acquired infections. So that's what you're seeing right here with these passive carriers, this little picture. So you've got this person who's taking care of this patient, and what did they probably not do before they went into the next room? Yeah, it's the number one thing we should do is washing our hands. But even if you wash your hands, is there a complete, safety thing? It isn't, because we were washing our hands, but did we still leave things on our hands? So you just try to do the best that you can do. But truly, nosocomial infections are serious. They cost billions of dollars each year in this country. And they can be avoided. I mean, you would think in a perfect world they can be avoided. Insurance companies, this is I don't know, maybe somebody would want to protest this, but insurance companies for some hospitals now are refusing to pay for an infection that they deemed a nosocomial infection. Is there any way we can avoid all nosocomial infections? No, there is no way. But this is absolutely why we also know that the best form of treatment, if we can, is to get that person in and out of the skilled care facility, right? Of the hospital or whatever. I mean, skilled care facilities, you're keeping them in for long times. But do you get what I'm saying? It's best to do that. And I know some people who say, well, I even remember when I had my kids, they were like, you only stay 24 hours. I was like, yeah, I'm getting out. You know, I'm getting out of there. You don't want to stay in there. You wouldn't want to, right? But I think it's kind of old school people thinking that, you know, and they'll say they just keep you out of the hospital with no whatever. No, it's probably best for you to get out of the hospital, right? You're already compromised. You're there for a reason. You're already compromised. And there's a lot going on in the hospital. And this can happen. So, okay, that I think they're self-explanatory, those carrier stages, so make sure you would just know. And the biological, you know, it's just this idea that it's participating in life cycle. So, for example, malaria. Malaria is a disease that's caused from a protozoa, and you all will want to know for these lecture quiz, potentially any of these that I've added to your list. Make sure you know these microbes by Wednesday. Malaria is caused from a protozoa that is known as, the genus is Plasmodium. There are 5 different species of Plasmodium that can cause the disease we call malaria. One of the species is Plasmodium malariae. One of them is Vivax, Ovale, Falciparum. You get what I mean? So there's 5 species. But I just want you to know the genus is Plasmodium. And it's a what? Protozoa. And I also want you to know that it depends, its life cycle depends on a mosquito. It's actually referred to as the Anopheles mosquito. So we could get rid of malaria if we got rid of what? The Anopheles mosquito, or if we got rid of humans, because we're part of the life cycle too. But okay, so we can either get rid of all humans, get rid of malaria, or we can get rid of the Anopheles. But is it really like going to be an easy thing to get rid of all the mosquitoes? Yeah, so they're doing things now with genetic engineering, though, to try to control the mosquito population without using these harsh chemicals. The chemicals that we were using, the pesticides we were using to treat the mosquitoes that cause malaria were so devastating to the humans that they had to back off of using some of those pesticides. But anyway, they are trying to do things. The good news about this, about malaria, well, if you're looking for good news, let me tell you the serious news first. More than 1 million children die annually from malaria. Can you even get your head around those numbers? If you think you can, you're not paying attention. That's horrific, isn't it? Is that horrific? Most of that is happening, again, if you look at the CDC site, you'll see that most of that is happening in a certain belt, a malarial belt in Africa, you know, where this is happening, but it is devastating. If you're looking for ways, good news about what's happened to try to control or help to control some of this, then we know a lot about the mosquito. This Anopheles mosquito, the only one that bites humans is the female carries this. And the female only feeds at night. So is that good news to have? So what should people do? So at night, hopefully there's somewhere where there's screens on the doors or windows, or they're sleeping under what? Tents. These little mosquito or the little nets, mosquito nets. So donating, there's an organization that donates and provides these nets, which are really, really cheap, to these areas that have high risk of malaria, and that has brought the numbers down to that 1 million. Imagine how much more than that. But anyway, and also through genetic engineering, they're trying to control mosquito populations. Yes, Jenna.
Only female mosquitoes bite you?
Yeah.
Just one specific.
And Anopheles mosquitoes, yeah, and these Anopheles mosquitoes also only are biting they only feed at night. So that actually, I mean, can you imagine if they were feeding all the time, how much more there would be? It would be so much more than that.
I get mosquito bites in the tail.
Well, pardon?
So I get mosquito bites in the tail.
Oh yeah, well that's not these
That's what I'm
mosquitoes.
saying.
Yeah, so,
I meant like all species or just.
oh, it's just this one that does the malaria. By the way, there have been malarial outbreaks even in Virginia. It was a long time ago that has happened. So malaria isn't just, we have Anopheles mosquitoes here too, but it's the Aedes mosquitoes that you all are seeing that carry Zika and some of the other diseases that we know, and they bite you anytime. So anyway, and knowing what the vectors need and what they do is a way that also can be used to maybe sometimes help to control. But what's really, I'm trying to think exactly what they're doing. Oh, they're doing through genetic engineering, they're making the males sterile. So that, I mean, that would work, right? If they could try to do that. But then you wonder if something else is going to happen because of that. But anyway, so they're trying to release enough sterile males out there that, that it will reduce the numbers of Anopheles mosquitoes. Okay. And then what do we call diseases that are spread from animals? That group is called what? Zoonotic diseases, right? And y'all have probably heard of, that those little turtles and lizards and stuff, they're filled with salmonella. So this is why, you know, and little kids obviously want to, and big people too, want to play with turtles and whatever, but they should really be careful, wash their hands carefully afterwards because salmonella is definitely a risk of that. Salmonella is going to be a genus of bacteria that causes salmonellosis, which, you know, can be serious, obviously. Salmonella typhi. So, yeah. All right. So zoonosis, I had just told you about. I think we already had that too. And you can look at some of the numbers of this and just see that, you know, this can be, you know, this is actually serious as far as emerging diseases go. I don't know if I have it on your list or not about SARS, S-A-R-S. Did I? I probably do under viral illnesses. SARS, S-A-R-S stands for severe acute, which sort of sounds redundant, doesn't it? Severe and acute together. But anyway, severe acute respiratory syndrome. When this outbreak happened, they realized it happened first in the Far East, and they were seeing these people coming in with a very serious respiratory disease and dying quickly. So its signs and symptoms progressed rapidly. Severe acute respiratory syndrome, S-A-R-S. Was that the question?
You said virus.
It's
Yes.
not here. She just didn't do it.
Oh, I just maybe don't have it on there, but yeah, I'm telling y'all now. So it's severe acute respiratory syndrome, S-A-R-S. So this outbreak happened quite a few years ago now, but when it happened, there were people dying of this respiratory disease that looked like nobody knew what it was causing it. And even one of the initial doctors who worked on patients who had it, that was one of the doctors that ended up helping to figure out what was causing it, what virus to cause it. He died from it. He died too from it. But so it was causing a significant death rate. And then they realized that it was this virus that was from these cats. It was a special kind of cat that they were eating, right? That they were eating in these regions. It was called, what was the cat called? I'm trying to think.
Civet.
Thank you. Is it up there? Or you just, oh, thank you. It is fine. Thank you.
I know things.
You knew it. So anyway, so it's a special kind. But these cats were part of the diet. And these cats had gotten it, so it had sort of jumped species to humans, and it was really very virulent, really deadly. So of course they went in and quarantined, and they tried to close down, you know, and tried to contain this. And at one point they actually closed down Toronto, the entire, you know, in Canada, because they closed the airports down because they were afraid that they were having an outbreak there. Can you all imagine what that does to the economy. Well, it really can really depress and hurt the economy. So it can, and that means that individuals, their livelihoods, their work and stuff will shut down. And so for a significant period of time. But anyway, so that was one of those little outbreaks that was pretty serious when it happened. We still sort of look out for that. So we've got viruses, bacteria. These are just some of the things that we know can be zoonotic diseases. And as I mentioned, them are going to be when you can actually take a look at that. So I talked to you about non-living reservoirs as well. Water, soil water being one of the ones that we really worry about some of the most. As far as experts go that think about the human population and overpopulation and the effects of human encroachment on the environment and that what it's doing to habitat, I think we had already mentioned that you all understand that it's through human activity that we're in the 6th major mass extinction event as far as how many species we're losing any given day or hour on this planet. Of course, geological time, it takes a little bit of time. It seems like a long time for us, but geologically it's like a blink of an eye type thing. But we are in the 6th mass extinction event, and it is because of human encroachment on the environment. So when people look at how humans are spreading, and growing and forming societies and whatnot, what is actually kind of agreed upon by most people who understand what humans are doing in their environment is that what's going to limit human population eventually is really going to be water. It's not going to be food. It's going to probably be water sources, adequate water sources, because water, potable water is less than 1% of all the water that's on the planet. So we have, the Earth seems so crazy because the Earth's covered in 70% water, but less than 1% of it are we actually able to drink. And now that we know that climate is changing, it's actually going to make that worse for many of the areas where humans live right now. So then humans are going to have to migrate in, and then that's going to change. And, they've looked at all these numbers and how much water is available. So what it might take is actually people just figuring out better ways to make water so that people are able to drink it. But anyway, it's probably going to be the limiting factor. And one of the reasons it's the limiting factor is because of the spread of disease. So I've told you what communicable and contagious means, and that each disease has its own rate of that. Some are easily communicable, some are not. Hepatitis B, is that easily communicable as far as like living on inanimate surfaces and whatever? It's pretty easy because it will live on inanimate surfaces for a long time. How about HIV? It's harder, isn't it? It's really harder. It won't live on inanimate surfaces. You're going to have to get an inoculating dose that's pretty high. Infectious dose, I say inoculating because you're getting it. But infectious dose that's pretty high, and it's going to take a direct body fluid contact, right? Some are incredibly easy because they're just respiratory borne diseases, but each one is kind of known. Okay, so this is non-communicable, means that you really don't. It's really hard to get it from host to host. How about Mycobacterium leprae? What does it cause? And what do we call leprosy? Kansas disease. Is it easily communicable? Not really. I mean, according to like some religious writings, it was easily communicable. That's why they were ostracized. But what we know about it is that no, it's not. And now that hasn't been done for a long time. There haven't been leper colonies. So there's different ways we transmit. Horizontal is one infected individual to another. Vertical means that you're going from like parent to offspring. So we've already said that a woman who's pregnant, can she transfer something to her fetus? Yes. Can women who are pregnant, who have just delivered, can they transfer disease through breast milk? Yeah. So somebody who's HIV positive status or female, if she's being treated, the risk of transferring that virus to the fetus through the uterus is very low. It goes down significantly. But there's no way, even if she's being treated, to decrease it in breast milk. So if a woman is HIV positive status, can she breastfeed? I mean, she could, but should she? No, because that will give that virus to the offspring. So, so these are just different routes of transmission. And it talks a lot about that. Yeah, that really would be. That really would be. So we, we kind of said that we talked about some of this. I'm gonna go on through. So I told you about healthcare associated or hospital acquired infections. Hospital nosocomial. Here's the spelling for it. For that.
Can you go back?
So here's what I want you to know about these hospital-acquired infections, or healthcare associated. Either one you want to say with that, or nosocomial. They all mean the same thing. Look at this. Look at the numbers. Urinary tract infections make up a significant, more than a third of all of them. Why would that be? How can you get a urinary tract infection from being in a healthcare facility? How can you get a urinary tract infection? Yes, it's definitely catheters. So in and out catheters that are being done just to get a urine sample to see if the person has a urinary tract infection. When you put in a catheter, even though you're using you're trying to create a so-called sterile fill, and you've got sterile, little catheters that you open up, and you're trying to keep everything like it's supposed to be. Can you sterilize the urethral orifice on somebody opening? You can't. So when you shove that into their urethra, up into their bladder, what have you also done? You've introduced normal flora to them. So, and even though the catheter tips are usually pretty soft and whatnot, that's invasive. That's an invasive procedure. So doing an in and out catheter on somebody really greatly increases their risk of developing a urinary tract infection. But also some people in healthcare facilities are also having indwelling catheters put in. Are all indwelling catheters put in because people are incontinent or have to have them? Janet, no. What other reason would they be being put in?
They can't urinate at all.
When they can't.
Attention.
Yeah, but also, believe it or not, and you can look this up, sometimes they're being put in because people are understaffed. And what you say?
I said, that's not right.
That's not right, but that happens. If there's understaffing and you know that person is going to, you're not going to have time to help them every single time, there will be people that come to your emergency rooms that have had these types of things happen to them before, and people just don't want to have accidents, if you will. It's humiliating for some people, and it's just a lot. And so what they'll do is they'll ask as soon as they get there, can I have a catheter put in? Because they know they're probably not they're going to have to wait a long time before they can get some help. And listen, I'm not blaming anybody for that. That's just the nature of some of this. You will see some of those patients come in that ask for that. Now, we're in a perfect world. You would hope nobody would ever get an in and out catheter or an indwelling catheter that didn't, specifically need it. And Janet, you said in your facility that's not happening, but that happens a lot. So, anybody else seen that happen? So I can't tell you how many times I've seen that happen where patients come in the ER, they know they're going to get a stay. And when they come in the ER, they immediately ask, can I just have a catheter? So anyway, indwelling or Foley catheter, these are ones that are going to stay in for an extended period of time. Surgical sites obviously make sort of sense. Respiratory-borne illnesses are so common anyway. I mean, that's like the easiest spread, right? So you sort of think about that. And septicemia. What is sepsis? What is sepsis? So sepsis is actively growing microorganisms in the bloodstream, actively growing. It is not the same as bacteremia or viremia. It is not the same. bacteremia means there's bacteria in the bloodstream, but it's not actively growing. And hopefully it won't stay in there long. It will come and go, right? Viremia is sort of the same thing, where there might be some viruses in the bloodstream. But septicemia means that person has an active bloodstream infection. And the mortality rate of septicemia is really high. So depending on what's causing it, the etiology, it is sometimes over 50%. And that's with best medical treatment. So mortality rate is really high on that. Did I have an arm up for a question? No? All right, so I'm going to keep going through here and see. So every single medical facility is going to have usually an infectious control person or an epidemiology, somebody that's actually designated as their epidemiologist. A lot of times they pull from like a nursing staff or whatnot, but they end up getting somebody that's designated for that to sort of monitor what kind of procedures are being used, the universal precaution procedures. You know, universal precaution means that you treat everybody like what? Like they've got everything. You treat everybody like they've got everything, and then you sort of cover. But you just make sure, I mean, you're not paranoid about it. You don't get paranoid about it but you just absolutely use those kind of procedures so that you are protecting yourself and you're protecting other patients. So barrier precautions are just what this suggests to you: gowns, aprons, those types of things. And you've got, masks, gloves. Those are the things that you're going to use. And so if there's anything that's special that's needed, it's usually going to be very much defined. Sharps precautions. So certainly people, learn, you go through orientation procedures. I know some of you all are already phlebotomists. How many of you are phlebotomists? Some of you. So you learn the procedures that you need to go through to make sure that you not just protect yourself, but protect people who are following behind you, that you don't leave anything out or that could be dangerous. So anyway, sharps just means anything that could actually cause a puncture wound or any kind of injury such as that. Dental precautions. We understand our mouth is filled with, it's very vascular, it's filled with a lot of normal flora, isn't it? And I do have people who are going into dental specialties, so we understand that too, and how you have to take care of the equipment between. Y'all probably don't remember this because I think it was probably more than 10 years ago, but there was a dentist in Florida who had become HIV positive. And he decided that he wasn't going to go out alone. So this was a significant time ago. And do you remember that, Michelle? And he was infecting all of his patients. And he was convicted and whatnot, but
I gotta go to the gymnast parents.
So has to see their autoclave. No, I'm only kidding. That's just
We'll give the cherries
criminal.
information more.
That's just really evil, wasn't it? They figured it out. Epidemiologists figured it out because they saw this. They saw people developing that were being diagnosed with HIV that really had absolutely no predisposing factors, and they were enough located in a little area that they started typing them. And guess what common denominator these people had? They're dentists. So that's how they call them. Anyway, so you can imagine though that these instruments that are used, in invasive procedures need to be treated correctly to prevent spread of disease. Hand washing, we said, is by far and away the best thing you can possibly do. Okay, and so anyway, some of these or whatever. Do y'all know about Koch, don't you? Do you know about his postulates and how to identify disease, etiologies of disease? Remember Koch's postulates? So I've already mentioned this to you. These are certain steps that you take to figure out what is causing the disease. You recover the disease from something that is sick, isn't that right? So somebody that is sick, you recover it. You end up growing that organism out. Is that your answer? Or do you have to do something else? then you take that particular organism, inject it into something that's healthy. That healthy specimen then gets that very same disease, and then you recover it from them. Do you remember that? Those were the steps of postulates. The germ theory of disease, these are the steps that get us to the etiologies. They're still being used today. Yes?
When you were working in lab, did y'all use like the rats and stuff?
I didn't do this myself, so no, I didn't do this, but this is what's being done.
I couldn't do that. I could not touch a rat in the pocket. They're so silky.
You got to dissect rats here soon. And
I mean,
amputate.
it's dead.
Oh, okay. Well, that was about to be. So,
We're just not just picking it up and injecting stuff into it.
Really, you're not picking up, you're just holding it down.
how many of you feel like, you feel like animals shouldn't be used? I mean, I don't, here's what I know. I mean, we wouldn't want to be testing humans. So, mice, the reason mice are kind of used is they have a relatively short lifespan, and they're easy and whatever. And they also have just easiest for us to keep and to watch and to monitor. I've had students who had pet mice, rats, I mean, not mice, but rats, since they were little. So I've had a couple of students who got really upset about it because they say, and then because of them, I did a little bit of research on it and realized that there are a lot of people who keep rats as pets, and supposedly they're great pets.
Yeah.
So have you heard that?
I've had pet rats.
You've had pet rats, and so I've had quite a few students. One student named Melissa. She really did. I wish I could do her justice in this, but she really did talk to that class about her rats and what some of her rats over the years. Because they don't live very long. They have pretty short lifespans. I mean, it's not like you're going to have a rat for 5 years. But anyway, or longer. But anyway, some of them can live a few years. And just how friendly and social they are. I had no idea. She told us stories. Yeah, rats. How friendly and social they really can be. So Melissa changed my viewpoint on rats, So anyway, but I still do get rats for dissection. So okay,
She's not.
who's not a rat?
I'm a ferret.
Yeah, so rats. There's little rats called mice, and big rats. I'm just kidding.
She sleeps in my little sister's. She's the sweetest thing.
Yeah, right.
We
Well,
love her.
well,
like literally, if she were to die right now, I would probably be completely heartbroken.
well, yeah. Oh, absolutely. Our pets mean a lot to us, and so the Melissa was talking about some of the things that her rats did, and she had little videos that she showed. Because I told her I didn't think it would be right to bring the rats in. So she only had like a couple at a time, But she had videos of what these little rats would like greet her and give her little kisses, and understood how to do things. I was like, oh my God, they're doing tricks.
Like,
This is like
they're cuddly and playful. They're
Yeah.
really tired a lot, but they're really sweet.
Yeah.
A ferret is one thing, a rat is another.
Does anybody go into PetSmart?
Yes.
Haven't you seen people in there with their rats? Bring them in? I've seen that several times when I've gone into PetSmart. I've seen people who are walking around with they brought their rat, and it's like, oh my goodness. That's what they are. That's what they look like. I know, rats. Did y'all see where the sewer workers? No, I don't think it was New York. I forget where it was, but the little sewer rat that it like took them a long time. It was a fat one, and it kind of stuck coming up out. Did y'all see that?
Those things I can't. You're talking about little sewer rat.
Yeah, but they're big.
That's a whole
And this little one that was like a little obese one, they said it was unusually heavy. And so anyway, its little hips had gotten stuck, and so these so it got, and then they released it. And all I could think when I was reading the article about these, these city workers releasing the rat, I thought, and then you're probably going over to the next avenue and putting things down to kill the sewer rats, So it's really kind of hard to know. But how could you kill it when it's stuck? You know, it's stuck. Like, okay, then you don't let that go, and then you're going to set a trap for it later. So, no, I don't know if that's good. Epidemiology. So y'all know this is really the study of how disease, everything about the disease, really. So the study of really frequency, distribution, certainly etiologies, right? It's really going to involve all of these different areas. And it's not just about infectious diseases. So it's not just that. That's just one category of that. So epidemiology. And so Florence Nightingale, she really did lay down the foundation for this because it was some of her findings when she went to battlefields and understanding. She was seeing that soldiers were not dying. More of them were dying from their wounds that were infected than the actual people who were getting wounds, you know, so that was what was killing them, the wound itself. Pardon?
So her name sounds like a Shakespeare.
Okay. So anyway, she really contributed a lot to the founding of epidemiology and to saving so many lives because of some practices that she put in. The doctors and those areas, if you look back at some of what was going on at the time, the doctors didn't want to take on those practices because they thought they were completely unnecessary. So she had to keep meticulous records so that she could then show proof of what should be being done. And you know, it's pretty impressive how one person really can make a huge difference and save lives. So this reportable disease thing, I think I've mentioned to you all that that some diseases, once people have been diagnosed with certain diseases in this country, by law they have to be reported because of the risk that they could have to the community. So this is a list I would just bring your attention to. It's on it's table 11.10 in your textbook. These are the reportable diseases in the United States. Now this does not mean that when your health department gets a notification from the hospital or the local clinic or hospital that a certain person has this, that your name goes with it. Your name and identity are protected, but the clinics, the hospitals, you know, whatever, they're by law required to report any of these diseases. They get reported first to the State Department, and then the State Department notifies the Centers for Disease Control, and all of the numbers are kept, analyzed, looked at. The data is collected, so it can be used to help prevent spread. Mortality rate, I think you all know the definition of mortality rate. It means the number of deaths that are expected of that particular infection, so the overall death rate that you would expect of that particular disease to be happening. Some of these statistics you can look at and see how, I'm trying to think what these were. So this is hepatitis C, incidence of acute hepatitis C from 82 to 2011. So you can kind of see this. And if you're looking at this, this is also why they decide that, you know, because this can be people can be silent carriers of this disease. So how much money they put into trying to go out and figure out, like, should people be tested, right? You all are hearing all the time about the baby boomers should go and be tested for hepatitis C. I don't know if I have them. I should. So anyway, if I'm not here, y'all know maybe what happened. Chlamydia, you can look at by age, you can look at all kinds of demographics. And then this is the trends in malaria. So you can see increased incidence in 2000 to 2012. So you can see some of these areas that I had mentioned to you before.
I'm thinking back. So it says MSM, MSW in women. What is the?
Where are you? Men who have sex with men, men
Okay.
who have sex with women only, and liars. No, that's not what. Oh wait, that's not up there. Sorry. Not sure why you said that. Sorry.
I'm sorry,
Okay.
what does that even mean? Oh my God.
I think we are.
Oh, my God.
But you're not really asking me what that means, so. Are you? Look, so when we talk about epidemics, you know, I talked to you what an epidemic is. This is going to be, you're going to have unexpected high numbers in a particular area, right? A particular location. The numbers of disease go up higher than you expect from that. So it can be point source, which means there was one person that sort of started this. And do epidemiologists often go in and figure out that point source, that index case, I called it? They can do that. Sometimes they figure that out. Common source means that it was maybe from spinach from this field in California, or this, you know, potato crop in, you know, Idaho, or whatever. Do you know what I'm saying? So they can actually see where the common source is. And propagated epidemic is going to be because this is communicable person to person, and it's just happening over a long period of time. This propagated epidemic is what's happening with the measles epidemics that are going on. They know they're going to battle that for quite a period of time, right, within those locations. Again, I told you what the index case meant, and I've already given you definitions for endemic. Endemic means that it's going to be found within a certain frequency within a geographical location, kind of at that rate, but you don't want to see those numbers going up. And then sporadic just means sporadically you'll have these little outbreaks. Pandemic, what did that mean? Yeah, around the world. So, you know, it's a lot. I promised you all that a lot of this was actually just repeat. So these, I think, can really help you to understand this terminology. So endemic cases, you're seeing that these are kind of there, they're sort of spread out, but there's not too many of them. Epidemic, you're having these little hot spots. You see the hot spots? And sporadic, just kind of throughout. And pandemic, you're seeing it across continents. So, look, I thought I'd get to start new material, but I can't. So it's not enough time. So just mark in your notes that this is the end for this, and we're going to start new on Wednesday. But I understand that on Wednesday, when we start some new material, that you all probably won't have to worry about taking lecture quizzes on that, because I really do want you to be going over these notes. Okay, any questions for me before we go to lab? Let me tell you what we're going to do in lab today.